Given this figure, are you going to use geometry or trigonometry? Good day everyone. Let's try to answer somewhat problem posted on Facebook. And special credits to the owner of this question. Unfortunately, I can't pronounce your name. So let's move on. Here's the question. Given this figure, our goal is to find its area. Now, if you want to try this problem, just pause this video right now. And if you're ready, here's the solution. And I hope you pause this video. Now let's see if you got the correct answer. Now, our first solution is using a pure geometry. And our second solution is, of course, using trigonometry. Now, let's start solving this question using geometry. First thing to do is to notice our given. We have alpha and 2 times alpha. Seeing this kind of given, my instinct told me that I need to break down these 2 alpha. Therefore, what we're going to do is to insert another line segment like this, such that this angle is alpha and this angle is also alpha. Now at this point, we can see that we have 2 equal angles. And if we have 2 equal angles, it follows that we have 2 equal sides. Therefore, these 2 line segments are congruent. Next, from this figure, we can figure out this angle. We can use the triangle exterior angle theorem, because the exterior angle theorem states that the measure of each exterior angle of a triangle is equal to the sum of the opposite and non-adjacent interior angles. Therefore, the measure of this angle must be equal to alpha plus alpha, or simply 2 alpha. Next, let's name the remaining angle as angle beta. Next, let's name this congruent segment as x. Therefore, this is x and this is also x. Now, since the whole segment measures 12 centimeters, therefore, the remaining segment must be 12 minus x. And the remaining side of this triangle, let's call this as side y. For proper naming, let's call the vertices of this triangle as A, this is point B, this is point C, and this is vertex D. Now at this point, we can now name some similar triangles. From our given, we can see that triangle ABC must be similar to triangle ADB. By simply noticing their angles, we have beta, we have alpha, and we have 2 alpha for triangle ABC. And for triangle ADB, we have angle beta again, 2 alpha, and we have alpha. Therefore, the 2 triangles are similar. Now, since they are similar, we can say that side AB over side AD must be equal to side AC all over side AB. Now, substitute all the given values. AB must be 8, AD is 12 minus x, AC must be 12 units, the total length of AC, and segment AB must be equal to 8. So what we're going to do is to solve for x. To do that, we need to cross multiply. Therefore, the left-hand side becomes 64 because 8 times 8, and the right-hand side becomes 144 minus 12x. Now, subtract 64 both sides and add 12x both sides, and we get 12x equals 80. Now, divide both sides by 12, and we get that x is equal to 20 over 3. Now, keep in mind that x must be equal to 20 over 3. In our figure, we can now replace the variable x, because we know x is simply 20 over 3. Therefore, this is 20 over 3, this is just 20 over 3, and this segment must be equal to 12 minus 20 over 3, or simply 16 over 3. Taking advantage with this similarity, we can also say that side AB all over side BD must be equal to side AC all over side BC. Substitute all their given values and we have AB, which is 8, BD must be 20 over 3, AC is 12, and side BC must be equal to y. Now what we're going to do is to solve for y. To do that, we need to cross multiply. Therefore, we have 8y equals 80. Divide both sides by 8 and we get that y equals 10. Therefore, the value of y must be equal to 10. Now we can replace this y with 10. Going back to our original diagram, we can say that this side must be equal to 10 centimeters. Now since we have the length of each side of this triangle, we can find its area using the Heron's formula. And the Heron's formula is equal to the square root of s multiplied by s minus a multiplied by s minus b multiplied by s minus c, wherein s is the semi-perimeter and a, b, and c are the lengths of the side of the triangle. Now let's solve for the value of s. This is just the semi-perimeter. Therefore, s must be equal to 8 plus 10 plus 12 divided by 2. Thus, the value of s must be equal to 15. We are now ready to find the area of this triangle. This is equal to the square root of 15 multiplied by 15 minus 8 multiplied by 15 minus 10 multiplied by 15 minus 12. Simplify and we get 15 times 7 times 5 times 3. Now take note that 5 times 3 is just 15. So 15 times 15 is 15 squared. Therefore, we can pull out 15 outside of the radical sign. It follows that the area of this triangle must be equal to 15 multiplied by square root of 7. And don't forget the unit. We have centimeter squared. And we're done. This is our first solution. Now let's proceed to our second solution using trigonometry. Now let's start. From our given, we have an angle and its opposite side. Therefore, it tells us that we need to use the law of sine. And in trigonometry, the law of sines, sine law, sine formula, or sine rule is an equation relating the lengths of the side of a triangle in any shape to the sines of its angle. So we have A over sine of angle A equals B all over sine of angle B equals C all over sine of angle C. Take note that we can use also the reciprocals of these terms. So, using sine law to our figure, we can say that sine alpha all over 8 must be equal to sine of 2 alpha all over 12. Now, using some identities, we know that sine of 2 alpha must be equal to 2 times sine alpha times cosine of alpha. Now, at this point, if we divide both sides by sine alpha, we can cancel out sine alpha. And 2 divided by 12 will give us 1 over 6. Now, multiply 6 both sides, we get 6 over 8 equals cosine of alpha. Simplify, and we get 3 over 4 equals cosine of alpha. Now, get the arc cosine both sides, and we get that alpha must be equal to arc cosine of 3 over 4. Now, keep in mind that alpha must be equal to arc cosine of 3 over 4. From our figure again, we know that the sum of all internal angles of a triangle adds up to 180 degrees. Therefore, the remaining angle of this triangle must be equal to 180 minus 3 times alpha. So that if we add all those angles, we get a total of 180 degrees. At this point, we have now the lengths of two sides of this triangle and its included angle. Therefore, we can now find its area. Using this formula, we have 1/2 times b times c times sine of angle A, or the included angle of side B and side C. In our given, side B represents 8 centimeters, side C represents 12 centimeters, and angle A represents 180 minus 3 times alpha. Take note that alpha must be equal to arc cosine of 3 over 4. Now, substitute all the given values and we have 1/2 times 8 times 12 times sine of 180 minus 3 multiplied by the arc cosine of 3 over 4. Now, simplify the result using our calculators and we get that the area of this triangle must be equal to 15 multiplied by the square root of 7. And don't forget the unit. We have centimeter squared. And we're done. If you have another solution to this question, feel free to use the comment section down below. And see you to our next video.